Topic 3-6, Part 3. You can compare numerical expressions with exponents that do not have the same base, as long as you can rewrite one or both of the expressions using the same base. In this problem, I'm comparing 5 to the 28th power and 25 to the 19th. Now, what I must do is I must try to raise both of these from the same base. You always try to use the smallest base. So I have 5 and 25, 5 being the smallest. So I'm going to try to raise both sides from base 5. Now let's think about 25. 25 is a perfect square. I can take the square root of 25. The square root of 25 gives you 5. And so remember that 5 squared is 5 times 5, which is 25. So I'm going to use that thought in rewriting the right-hand side from base 25 to base 5. Now the left-hand side is already raised from base 5 to the 28th power. I'm going to write 25 as 5 squared. Write 25 is 5 squared and then raised to the 19th power. So 25 is now written as 5 squared. Remember, when one exponent is inside and one exponent is outside, we multiply the exponents together. 2 times 19. Therefore, I get 5 to the 38th power. So in comparing 5 to the 28th and 5 to the 38th, my bases are the same. They're both integers raised to exponent. The exponent with the smaller value is less than the one with the larger value. So this would be 5 to the 28th is less than 5 to the 38th. The one with the smaller exponent is the smaller value. 5 to the 28th is less than 5 to the 38th. So let's look at a few more examples with this type of problem. Let's look at this one. Comparing expressions by rewriting terms as powers with the same base. Use less than, greater than, or equal to complete each statement. Well, the left side's already raised from base 18. Let's work on the right-hand side. 9 to the 10th, I can rewrite 9 because the square root of 9 is 3, and 3 squared is 9. I can write 9 as 3 squared raised to the 10th times 3 cubed. You're trying to write them from the same base. When one exponent's inside and one exponent's outside, we multiply. We get 3 to the 20th times 3 to the 3rd. Continuing on the right-hand side, when you are multiplying like bases, don't we add exponents? So we have 3 to the 20 plus 3. Therefore, on the right-hand side, I end up with 3 to the 23. So how does 3 to the 23 compare to 3 to the 18th? I have 3 to the 18th that I've just kept in my problem coming on down. So now they're both raised from the same base to one exponent. 3 to the 18th is smaller than 3 to the 23. I have integers raised to positive exponents. The one with the smaller exponent is the smaller value. So 3 to the 18th is less than 3 to the 23rd. Let's look at the next problem. 4 to the 21st, how does that compare to 2 to the 28th times 8 to the 4th? Now, what we want to do is try to raise both sides from the smallest base. Well, comparing my bases, I have a base of 4, 2, and 8. Can we raise every one of these numbers from base 2? Well, let's think about it. 2 squared is 4, and 2 cubed is 8. 2 times 2 is 4, and 4 times 2 is 8. So yes, I can raise both 4 from base 2 and 8 from base 2. So I'm going to rewrite 4 as 2 squared to the 21 power. Now, if I multiply those together, I get 2 to the 42. And how does that compare to the right-hand side? Well, I already have 2 to the 28th times. Now let's write 8. How do we write 8? 2 cubed is 8. So I've replaced 8 with 2 cubed to the 4th power. So I have 2 to the 28th times, again, if one exponent's inside and one's outside, we multiply them. 3 times 4 gives you 12. Now that we are multiplying like bases, we will add exponents. 28 plus 12, if you punch that in your calculator, you will get 2 to the 40th. So I end up getting 2 to the 40th on the left side, and I end up getting 2 to the 42 on the, this is on the left and this is on the right. So 2 to the 40th on the right and 2 to the 42 on the left. Therefore, same basis raised to exponents. The one with the smaller exponent is going to be the smaller value. So this would read 2 to the 42 is greater than 2 to the 40th.